Welcome to Ask and Learn.
All right, so here we want to show that f of x is big theta g of x if and only if f of x is big O g of x and g of x is big O of f of x. All right, so first we show that if f of x is big theta g of x, then f of x is big O of g of x, and g of x is big O of f of x, and then we'll show the other direction, right? So first, we're kind of going from left to right of the statement, and that means that we assume that f of x is big theta g of x. So by definition of the big theta notation, this means that f of x is big O g of x, and f of x is big omega g of x. Okay, well, if f of x is big O g of x, then that sort of takes care of the first condition, right? And so then let's continue with f of x being big omega. Okay, well, if f of x is big omega of g of x, I forgot the brackets here, then by big omega notation, there exists a c and a k such that the absolute value of f of x is greater than or equal to some constant times the absolute value of g of x. Right, so for whenever x is larger than k. So if we divide each side by c, then what we get is 1 over c times the absolute value of f of x must be greater than or equal to the absolute value of g of x. So if we let c1 be equal to 1 over c, then we get c1 times the absolute value of f of x is greater than or equal to the absolute value of g of x when x is greater than k. All right, well, by big O notation, though, this means that g of x is big O f of x, where our c, right, is going to be this c1. So we have our c1 is equal to 1 over c. Okay, so that takes part of this second condition. So this way that if f of x is big theta, then it implies f of x is big O of g of x and g of x is big O of f of x. So now we want to move in the other direction, right? So we're sort of going from the second statement to the first. So in this instance, then we assume that f of x is big O g of x. And also that g of x is big O of f of x. Okay, well, so by the definition of big O notation, then there exists constants c and k such that the absolute value of g of x is less than or equal to some c times the absolute value of f of x. Right, and this is just the case where g of x is big O of f of x. Right, so for x being larger than some k. So if we divide each side by c, right, then we get 1 over c times g of x is less than or equal to the absolute value of f of x. When x is larger than k. So if we let c1, so the same trick as last time here, be 1 over c, then this implies that c1 times the absolute value of g of x is less than or equal to the absolute value of f of x when x is larger than k. And so by definition of the big omega notation, this means that f of x is big omega with g of x when we choose x larger than k and c1 equal to 1 over c. And therefore, f of x is big O g of x, right? Because it's in the assumption here. A different color. So we assumed that it's big O g of x, and we've shown then that it's also big omega g of x. And so if it's both those things, then f of x is necessarily big theta g of x. All right, and then that will conclude the proof.